Now I introduce Q-learning. Q-learning is one of the most important reinforcement learning methods. Q-learning solves the Bellman temporal difference equation for the optimal policy through a Q distribution. The Bellman equation for the Q value function is written in this formulation. First term is a last value, or we can call current value. We update the new value through this temporal difference. Temporal difference, this is the learning rate, this is the future discount rate, and this is the reward from the environment. And this is at the state as t+1 by selecting this action A prime makes this Q maximum. From this maximum value, and then now we get this temporal difference, we update to get this increment for the Q value, then we get updated, estimate the new Q value. So that means an agent at his current state and selects action A under policy pi, then it at this point. We need to estimate the Q value at this point. To estimate the Q value at this point, we need the reward from the environment. And then our agent moves from his current state to next state. At next state, agent needs to scan this new action prime, see which action can generate the maximum Q value. Then now we get this maximum Q value, we can update this Q value at this point. From here, for example, each cell stands for a state. If we need to calculate the Q value at state S by selecting this action A, so we need first agent move from current state to next state, receive this reward, and then see how many choices. That means how many A prime can be selected. If, for example, this move up can bring the maximum Q, then now we use this maximum Q in this formula to get this temporal difference, then update to the new Q value here. Once we have the Q distribution, then we calculate the optimal policy pi, because we need only calculate, find the A makes this temporal difference maximum. And then from Q value by finding action A makes this Q maximum, we find the optimal state value function V. Let's see an example. Use this system. We use this formula, and then now we make this formula in a iterative method. Iterative method, then now we can step by step update the Q value at each point until we get the convergence. Then now we got the Q distribution, find the optimal policy. Let's see, start from K equals 0. That's beginning with initial condition. Initial condition make all the Q equal 0. Then all the Q is 0. And then when K equal to 1, because all the Q equal 0, R equals 0 only, when move to the goal, R equal 100. Rest of them, R equal 0. When K equal 1, then all the Q is 0 except 2 next to the goal. So for example, to calculate this Q at this state by selecting this action, And then we see because this now this equals 0 and this 100, and this also equals 0 because this terminate. So this is 0. From here, so we can this calculate we can get this Q equal 100. Similarly, this Q also equal 100. Then we move to the K equal 2. K equal 2, that means we calculate the Q here at this point. Is this data by selecting this action A, right? And then from here, because this 0, this previous Q is 0 is here. Alpha is the learning rate. This R, this is 0 because there is only non-zero R here, 0. And here, this is the future discount rate, 0, suppose 0.9. And this is 100. 100 means at the next stage, we have two actions. One is right. Then now we can, we already get the 100. Another direction is down. Is down here is this, is 90, and this is 0. So the maximum is 90. 90 is 90 is here. 90 is here times 0.9, so it's 81. So one is 81 return. One is action can produce the Q equal 100, so we use 100. We not use the 81. And then this is its previous value. So we got the 90. That means for the at this state, select move right action, and then we can get the Q value at the state S by selecting this action. We get the Q value is 90. And then see if we move further to the K equals 3. K equals 3, everything is the same except this one is 0 changed to 72. So the same thing, we calculate the Q at this state by selecting this action. And first this R equals 0. And then we see at this state how many actions we can select is 2. One is right, we get 100. One is down. Down, is here is two choices. One is 90, one is 72. So we select 90. 90 is times the future discount rate, 0.9. So still is 81. So to calculate the Q as this state by selecting this action, we still use this largest Q maximum. That means the action moving to right at the S t plus 1. So that means same thing, we still get the Q value is 90. That means already get the convergence result. Once we get the convergence result, we get this Q distribution. For example, from this state, by selecting this move right, Q is 90. Move down, Q is 72. So this is maximum. At this stage, we are selected moving right, get 100. Moving down, get 81. Move left, get 81. At this stage, we calculated if we select the right, get 90. Left, 72. Up, 90. So from the distribution, from the formula, we could calculate this maximum, this optimal state value function, we get 90, because this is maximum 90, this is 100. This is 90, and this maximum is 81. This 100, this is 100. So we got this optimal state value function distribution. And the optimal policy is here at this state. We select, this is the maximum Q. We select this moving right, and here moving right, here moving right, here moving up, here moving right, here moving right. And then we get this optimal policy. For more details, please check with this reference. Thank you.